So, vectors. We have already discussed vectors. Vectors are those physical quantities which have both magnitude and direction. Now, examples, we can take velocity, acceleration, force, momentum, etc. So, these all are vector quantities. Now, how a vector is represented? The vector can be represented with a straight line. Now, suppose you want to represent a vector A. Now, this is a vector A. Okay, so this is represented, as you can see, is a straight line with an arrowhead on it, or this is an arrowhead or an arrowed line. Now, the length of the line drawn on a suitable scale represents the magnitude of the vector, and the arrowhead tells the direction of the vector. The starting point of the arrowhead line, this is known as the tail or the origin of the vector, and the end of the arrow line is called tip, or this is the head of the vectors. Now, so this is how you represent a vector. Now comes the unit vector. Now, what is a unit vector? Now, a unit vector of a given vector is a vector of unit magnitude and has the same direction as that of the given vector. Now, suppose you take vector A. Okay. Now, the magnitude of this is represented by A only, and the unit vector of A is represented as A cap. So, this is the unit vector. So, this unit vector, you can obtain this unit vector as a vector divided by its magnitude. So, this gives you a unit vector. So, unit vector is a vector divided by its magnitude, that is a unit vector. Or you can say a unit vector in a given direction is also defined as the vector in that direction divided by the magnitude of the given vector. It is unitless and dimensionless vector and represents only direction. So, it represents the direction of the original vector, but has a magnitude as 1. Now, you know that in a Cartesian coordinates there is x axis, y axis and z axis. Whenever we want to represent the position of any particle on a space or 3-dimensional space. Now, the unit vectors along these directions is represented as I cap, j cap or k cap. So, the Cartesian coordinates I, j, k are the unit vectors along the x axis, y axis and the z axis. So, I, j, k are the unit vectors, x axis, y axis and z axis. Now, equal vectors. Now, equal vectors. Two vectors are said to be equal if they have equal magnitude and same direction. Now, consider this. These two vectors, this is vector A, and if you take this as vector B, now vector A will be equal to vector B only when they have same magnitude and same direction. Now, even if you like suppose if you take the vector A, okay, now we draw another vector in opposite direction, but of equal magnitude. So, that is represented as minus A. So, this minus A, the minus sign is because of opposite direction. Okay. So, same as we can define a negative of a vector or negative vector. Negative vector. Now, a negative of a vector is the given vector. Sorry, a negative of a vector of a given vector is the vector of same magnitude, but acting in a direction opposite to that of the given vector, as I have explained in this. So, this is minus A, so negative vector, though they have equal magnitude, but the sign will be different. Now, same you have like what do you call the co-initial vector. Now, co-initial vectors are those vectors which have the same initial point. For example, if you take this as A vector, this is A, you can name this as P. So, OP is actually a vector. Similarly, vector B, you represent vector B like this will be Q. So, A and B, they are co-initial vectors. Why? Because they have initial common point. Now, collinear vectors. Collinear vectors. Okay, now these are those vectors which are having equal or unequal magnitudes and are acting along a parallel lines or along the parallel lines in same direction or along a parallel line in opposite direction. So, by the definition, this vector A and this vector B, they are collinear vector. Vector A, vector B, collinear vector. A, even if they are acting in opposite direction, this is B. Now, one more thing is coplanar vector. Coplanar vectors. Now, coplanar vectors are those vectors which lie in the same planes or in same planes. Now, if I draw three vectors like A, vector A, vector B and vector C in the copy. So, that means they are on the same plane. So, A, B, C, these are coplanar vectors. Vector and displacement vector in a plane. Now, take this. Now, you take this as a coordinate axis. Coordinate axis. Now, A is a point on the plane. Now, suppose we want to have a position vector. So, if we draw a line OA, okay. Now, taking this, drawing a line OA. So, this OA is called the position vector of A. So, this is the position vector. Yeah. So, this is a position vector. Now, suppose in time t, in small time interval t, the object has displaced and had reached to the point, consider this point as B. So, this is the point B. Okay. Now, if we draw a vector from A to B, now take this vector from A to B. Okay. So, AB is what? AB is the displacement vector. Now, this is the displacement vector. Now, the position vector of B, taking O as the origin, the position vector of B will be like this. So, this is the position vector of B. So, hence OA is the position vector of A, OB is the position vector of B and AB is the displacement vector. Now, if we write AB, the displacement vector AB, you should memorize this, that AB is actually given as OB minus OA. That is the displacement vector AB, that is equal to the position vector of B minus the position vector of A. Now, multiplication of a vector by a real number. Now, suppose if we multiply a vector by a real number, then what we get is another vector whose magnitude becomes n times or times that number, but the direction that remains same or opposite according to the sign of the given number. Now, you take, for example, this is vector A. Okay. Now, what is 2A? Now, this is the scalar multiplication. The 2A is just you get twice of this vector, but the direction remains the same. Similarly, if you do minus 2A, so minus 2A will be this, means twice of this vector. Since this is minus, so you will get a direction opposite to this. Now, what is a resultant vector? So, we have discussed many vectors. Now, what is a resultant vector? Actually, resultant vector of two or more vectors is defined as the single vector which produces the same effect as produced by the individual vectors together, individual vectors put together. Now see, these are vector quantities. We cannot add vector quantities by simple law of algebra. So we need some like the laws of vectors. So first law, yeah, or you can say an analytical method of vector addition. So that first part is actually the triangle law of vector addition. Now this is triangle law of vector addition. Now triangle law of vector addition. First of all, what does it states? The triangle law of vector addition states that if two vectors acting on a particle at the same time is represented in magnitude and direction by the two sides of a triangle taken in one order, okay, then the resultant vector is represented in magnitude and direction by the third side of triangle taken in the opposite order. Okay. So just for the explanation, suppose there are two vectors, vector A and vector B. Okay, this is vector A, this is vector B. Now we want to add it. Now see, if we displace a vector parallel to itself, the vector remains unchanged, that you should know. So if I take A to this side, A to this, so this becomes vector A. Now see, these two vectors should be in same order. So this is A and vector B like this. Parallelly I am displacing, so there is no change. This is vector B. That means the tail of the arrow, the tail of this vector should coincide with the arrowhead of this vector. Now see, they are in the same order. Now what is the resultant? Resultant is this. So the resultant R is given as vector A plus vector B. Now this is the resultant vector, which is actually in opposite, taken in the opposite order. So this is what the triangle law of vector addition is. Now consider, now we actually have to find the magnitude. Consider this. Now see, this is vector A, this is vector B. Okay. Now they makes an angle theta with each other. So by the triangle law of vector addition, when you add them, now this is the resultant vector. Now see, what we are going to do is that I will be telling you the formula of the magnitude of the resultant, and now since this is a vector, so this will have direction. So that's why I have taken beta to be the direction of this vector, because since this is a vector, this will have magnitude as well as direction. So let it make an angle beta with the vector this. So A and B are two vectors having angle theta with them. Now this is just for the construction, take this point as n. Now I suppose we have to write Pn. So using trigonometry, Pn will be actually B cos theta, Qn will be B sin theta. Now what is the formula for the resultant of this vector? To get the magnitude of this thing, the formula is R is equals to, you take under root, this is A square plus B square plus 2AB cos theta. So this is the resultant of the vector A and B, the magnitude of resultant, A square plus B square plus 2AB cos theta. Theta is what? Theta is the angle between the two vectors. So theta is this angle between two vectors A and B. Okay. Now the direction. Now see, tan beta. Now I am taking tan beta. This is actually equals to Qn. Now see, Qn by On. I will show it to you. Now see, this is a triangle. Now this is a right angle triangle. Taking this is beta, tan beta will be Qn, means the opposite by adjacent or perpendicular by base. So this is On, Qn by On. Okay. Now what is Qn? As I have already told, Qn is B sin theta. So this is B sin theta, and On is actually, this is OP plus Pn. OP is A plus B cos theta. This is A plus B cos theta. So this is tan beta, and this is how the direction of this resultant is given. This one is the magnitude under root of a square plus b square plus 2ab cos theta, and tan beta is b sin theta upon a plus b cos theta. Okay. Now the second part is the parallelogram law of vector addition. Now part B is parallelogram law of vector addition. Parallelogram law of vector addition. Now it states that if two vectors acting on a particle at same time can be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented in magnitude and direction by the diagonal of parallelogram drawn from the same point. Now see, you take this. Now taking this as a particle, so this is vector A and vector B, theta is the angle between them. Now see, we can complete a parallelogram. Now this is actually can be represented by, now these are the two, taking these are the two sides of parallelogram. Okay. Okay. Now these are, now this is a parallelogram. We can name the parallelogram. This is, you can take this as P, this as Q, this as S. So basically R will be what? R will be the resultant of the two vectors. So this is the resultant vector diagonal whose direction is given in this. This R is the direction of the two vectors, and this is angle theta. So this angle has to be theta. So this angle has to be theta. Okay. Now same thing. If we complete this, we will get the same thing as one was the previous. So this is n. So the same theory will apply as we have done in the triangle of vector addition. Same, the resultant R, which in case is this, that will be given by under root of, this is under root, this is a square plus b square plus 2ab cos theta. Theta is the angle between the two vectors. So you see, this is the theta angle between two vectors, this is theta, the angle between the two vectors, and tan beta is same. Tan beta is again the same as the previous one, qn by on, that is equals to b sin theta upon a plus b cos theta, as theta is the angle between the two vectors. Now see, there are some special cases also of the like triangle of vector addition. Now the first case is that when the two vectors are acting in same direction. So if they have same direction, then what is theta between them? Theta between them is 0 degree. So we know that what is cos 0 degree? Cos 0 degree is 1, and what is sin theta? And what is sin 0 degree? Sorry, that will be 0. So if we find the resultant using this formula, R is under root of a square plus b square plus 2ab. Now cos 0 is 1, this is 1. So this is actually the formula of a plus b whole square. So this is equals to under root of a plus b whole square, which is equals to a plus b. So, and tan beta, the value of tan beta, that is equals to tan beta is actually equals to b sin theta upon b plus cos theta. So b sin theta actually that will become 0. So this will be b into 0 upon a plus b, because cos theta, but this will be 0 only. So beta is equals to 0 degree. Now you can see that for two vectors acting in same direction, the magnitude of resultant vector is equal to the sum of the two vectors and acts along the direction of a and b, because beta is 0. So beta is 0 means This angle is 0, so resultant will be in this direction only. Okay. Now, second case, when they are acting in opposite direction. So, now when they are acting in opposite direction, theta is what? 180 degree. We know that cos theta is -1. So, resultant will be, so this will be the formula of a square plus b square minus 2ab, which is a plus, which is under root of a minus b whole square. So, r is what? Is a minus b. And what is beta? Beta will again be 0. So, two vectors acting in opposite direction, the magnitude of resultant vector is equal to the difference in the magnitude of two vectors and acts in a direction of a bigger vector. Now, when two vectors acts at right angle to each other. Now, two vectors, they are acting at right angles to each other. Right angle means C. This is vector A. This is vector B. This is 90 degree and take this as the resultant R and this angle as beta. Okay. So, what is R? Cos 90 is 0. So, this is under root of A square plus B square plus 2AB, but this is 0. So, which is equals to under root of A square plus B square. And what is tan beta? Tan beta will be equals to tan inverse of, tan beta will be B by A actually. So, beta is tan inverse of, so this beta is tan inverse of B by A. So, this is the case when they are acting 90 degree to each other. Okay. Condition. Now see, if three vectors acting on an object at the same time are represented in magnitude and direction by three sides of a triangle taken in same order. That means if this is consider this as OP vector, OP, okay, or you can say this as A vector, this as, you can consider this as PQ vector, or this is B vector. Now in the same order means now this is the vector which is QO, or which is vector C. So now this is the condition. Now are represented in magnitude and so if the three vectors acting on an object are represented at the same time or can be represented in magnitude and direction by three sides of a triangle taken in same order. Now in this case, what is the resultant? The resultant is 0, because by the vector definition the initial and the final position is same. The net displacement is 0. Now this is called the object is in equilibrium. As you know, in equilibrium the forces adds up to 0. Now considering the three vectors A, B and C acting on an object at the same time, now they are represented by vector OP, means the side PQ and QO of three sides of a triangle. Now this you should know, we can represent this as, this is a condition which we can write A, that is vector A by OP is equals to B by PQ, that is equals to C by QO. Now similarly, if a number of vectors acting on an object at the same time are represented in magnitude and direction by various sides of a closed polygon taken in same order, the resultant vector is a 0. Now there are some important facts of the vector addition. Okay. So some facts about the vector addition. First of all, as we know that the like quantities can be added together. So the vectors of same nature can be added, like force vector can be added to a force vector only, not to a velocity vector. Second, the vector addition is commutative. Commutative means vector, if you write vector A plus vector B, so this is equals to vector B plus vector A. This is commutative. Same goes for associative, that vector addition is associative, that if you write A plus B, put this in bracket, plus C, so this is actually vector A plus B plus C. Now this is an associative law. The vector addition is associative. So these are some facts about the addition of vector. Now subtraction of vector. Subtraction of vectors. Now see, subtraction of vector A from vector B is actually defined as addition of vector minus B, or you can say that like addition of vector minus B onto vector A. So basically if you want to write A vector minus B vector, so this can also be written as vector A plus of minus B vector. That means we are adding minus B vector to A vector. Now yes, consider this. Now this is vector A, this is vector B. They are having angle theta between them. Okay. Now we have to minus this vector. So what we do is that we take minus B vector, and that will be in same opposite direction. So this will represent what? This will represent minus B vector. Now as you know, they are on the same, means same direction, and this resultant which is in opposite direction, this will be the resultant vector which is in opposite direction, that will represent the resultant of these vector. So this is vector A plus of minus B vector. So this is how the subtraction of vector works. Now you see, if theta is the angle between vector A and vector B, then between A and minus B, this will be 180 minus theta. So if you take the angle between A and minus B vector, that is 180 minus theta. Okay. Now from the results only, like if you take the magnitude R, so this is under root of A square plus B square plus 2AB. Now what is the angle? Cos, this is 180 minus theta. 180 minus theta is the angle between them. Okay, and tan beta will be equals to B sin 180 minus theta, and this will be A plus B cos 180 minus theta. This is just a replacement of theta by 180 minus theta, because the new angle is 180 minus theta, that's why. Now again the important facts about subtraction of vector. First, for subtraction of vector is not commutative. So A minus B will not be equals to B minus A. Similarly, this will not be associative. So this is like if it is vector A minus of vector B minus vector C, this will not be equals to A vector minus B vector minus C vector. So this is not an associative vector. Just a second, this is a zero vector. Now what is a zero vector? A zero vector is a vector which has zero magnitude and an arbitrary direction, means a random direction. A zero vector is represented by a 0 over the number 0 and is also called a null vector. So this is a zero vector. So it's obvious that its magnitude is going to be 0 and the direction is arbitrary. You can take like any direction. Illustration of zero vector. Now see, when a vector is multiplied by a 0, see, if you take a vector A, you multiply this with 0, what you get is a zero vector. Simple. Now the result of addition of a vector to its own negative vector is a zero vector. Similarly, if you take vector A and you add minus A to its, what you will get? You will get zero vector only. Okay. Now suppose you want example of zero vector. Now The example of zero vector is, for example, the velocity vector of a stationary particle is a zero vector. And also the second example, the position vector of the origin of coordinate axis, that is also a zero vector. Okay. Now the resolution of a vector. Now see, as we know that the two vectors can be combined together to form a resultant vector. Similarly, a single vector can be split into its component. That is called the resolution of a vector. As such, the vector can be added, so it can be split into a component. Now, the rectangular components of a vector in a plane. Okay. Now you consider a vector A. Okay. So generally we take its two components, the rectangular components. If you take, and this makes an angle theta. So this is the coordinate axis. This is x axis, this is y, makes an angle theta. Now OP is what? OP is the horizontal coordinate. So OP is basically AX, which is equals to A cos theta. And similarly OQ is AY, that is A. So these are what? The rectangular component, the magnitude of the rectangular components of this vector. Similarly, I and j are the unit vectors along the x-axis, and this is along the y-axis. So a vector A, now to write a vector A, this will be Ax I cap plus Ay j cap, or vector A can be written as Ax is what? A cos theta I plus A sin theta j. Actually, there is one more point. You see, theta is actually you have taken as the horizontal, but the cos theta component we generally take of the side which is adjacent to theta. Now, if you consider it like this, now I am replacing it. Let this be x-axis and this is y-axis. Now the vector is such that it makes an angle theta with the y-axis. So now the ax, or means the component, this one will be a cos theta, though you can take this as vertical, and this will be a sin theta only. Okay. So now extending it to the three-dimensional plane. Now if we extend it to the three-dimensional plane, so considering this as you write, see, like I, j and k. So these are the unit vectors along x-axis, y-axis and z-axis. So for all this, vector A is equals to Ax I cap plus Ay j cap plus Az k cap, where I, j, k are the unit vectors along the x, y and z axis. Now, the example of the rectangular components of vector in a plane. Now you consider this block whose weight is mg acting vertically downward. This is on an inclined plane. Let this inclined plane be, this makes an angle theta. Okay. Now see, this block mg, actually now the weight is divided into its two components. Two actually component which are rectangular components. So one is acting along this direction and one is acting along this direction. Now how to resolve this? Or you can extend this, this is mg. Okay. Now how to resolve this? Now see, in the rectangular components, first of all we should know where is theta acting. So if you take this triangle, okay, you know that this is theta, this is 90, so this will be 90 minus theta, this will be 90 minus theta. Now again, if this is 90 minus theta, this is 90, then this angle is theta. Okay. So this will be mg cos theta and this will be mg sin theta. So actually this direction, because of this direction of force, this is going down and the weight is actually causing by this mg cos theta. So these are the two rectangular components of mg. Now taking another example, now consider this block is being hanged with two strings. The weight mg is acting vertically downward and there are two strings. This is the tension in the one string T1, take the tension in the string as T2. This makes an angle 45 degree, 20 degree. Now the rectangular components, so it will be like this. See for T1, now T1 you have to do it like this. Now T1 is what? This is 45, this is 45. So components will be, this one is T1 cos 45 degree and this is T1 sin 45 degree. 42, this is 20. Oh, I have done a mistake. I am really sorry about this. Cut all this. Sorry. This is 45, actually this is 45, not this one. This is 45. So this will be T1 cos 45 degree and this will be T1 sin 45 degree. I am really sorry about the mistake. If this is 20, then this is also 20. Okay. So this is T2, this is vector. Now resolving it into rectangular components, this will be T2 cos 20 degree and this will be T1 sin 20 degree. Now we have resolved the forces. Now you can balance it because since this is an equilibrium. So these two, T1 cos 45 will be equal to T2 cos 20 and mg will be equal to T1 sin 20, T1 sin 45 degree.